Good afternoon, everyone. I'm going to talk about how we need the null, but perhaps somewhat paradoxically, in telling you about how we need the null, what I'm actually going to say is that we need to be explicit about our alternative hypothesis. All of this will become clear momentarily, but we start with a paradox. Unfortunately, what we have to do first, what we have to do first is delve back in a little bit of logic, but I'll give you a nice example so that you have an idea. It's called the modus tollens, and the idea is, if h, then not x, x, hence not h. H here you can think of as a hypothesis, and x as a certain event from happening. So if a certain hypothesis were to be the case, then x cannot occur, x occurs, hence the hypothesis is not true. For instance, say you're talking on the phone to someone and you don't know for certain if this person is a male or a female. A possible line of argument could go, if this person is male, then the event of this person being pregnant cannot occur. Later in the phone conversation, you might learn that this person is pregnant, and now you can conclude that this person is not in fact male. Makes sense, right? Completely valid line of reasoning. However, now I'm going to switch to what we do when we do null hypothesis significance testing. And that changes this line of reasoning ever so slightly, but in a way that no longer makes it valid. Like this. If a hypothesis were true, then x is unlikely. X occurs, and now we conclude that the hypothesis is not true. Sounds still fair enough. Let me give you an example. This is not one I've come up with myself. It's called Jane, the American Congresswoman. And the logic goes like this. The hypothesis here, Jane is an American, H. If Jane is an American, it's unlikely that she is a congresswoman. This is a perfectly valid statement, right? Of the many Americans that are there, only a fraction of them will be congresswomen. Number two, Jane is in fact a congresswoman. And then we conclude that Jane is not an American. You can clearly tell how this line of reasoning is flawed, and the reason it is flawed is because we're not explicitly specifying the alternative hypothesis. The alternative here being Jane is not an American. If Jane were not an American, then it's impossible for her to be a congresswoman. Does this sound contrived to you? Well, let's switch to a real-world example where this exact line of reasoning was used and did great damage to a person. The case of Sally Clark. Sally Clark had 2 of her infant children die. And she was later prosecuted for having murdered her own 2 children. The line of reasoning that was followed here is, if Sally Clark were innocent, H, then her 2 children dying is unlikely to have occurred. Her 2 children died. Hence, she is not innocent. But consider the alternative, right? How likely is it that a mother murders her own 2 infants? Using something called Bayesian statistics, you can pit these 2 things against one another. How likely is it that 2 infants die in succession from sudden infant death syndrome versus how likely is it for a mother to murder her 2 children? Using Bayesian statistics, you can work out that in fact the latter is much less likely, and based on this different perspective, she was later acquitted of something. Just an example, right? Why am I giving you this whole story? Because I think it's very important in all the research that we do that we don't just work with one decision criterion, i.e. reject the null or fail to do so. Because by doing this, we can never find evidence in favor of the null, and we tend to overstate the evidence against the null. One line of research this kind of thing is particularly important in is the area of replication studies. And in what time I have left, I will show you 3 replication studies and Bayesian statistics as a means of assessing both the null and the alternative. Essentially, what we're getting is a conclusion in the sense of the null hypothesis is x times more likely than the alternative giving the data, or the alternative is x times more likely than the null giving the data. This is something that is not possible to do with traditional null hypothesis significance testing. The first example I'll give you is the kitchen rolls experiment. I will not give any author names of the original studies. If you're interested in that, I'm sure Google Scholar will be great. I will, however, tell you the logic of the studies. And the kitchen roll study is as follows. The idea is, in the experiment, participants are seated in front of a peg with a kitchen roll around it, and in one condition they're asked to turn the kitchen roll clockwise, and in the other one they are asked to turn the kitchen roll counterclockwise. The hypothesis that was confirmed by the original researchers is, if you turn clockwise, this puts you in a frame of mind to the future. As a result, doing this will lead to more forward thinking. And if you turn it counterclockwise, the reverse will happen. Some researchers in a pre-registered proposal have attempted to replicate this experiment and found, this might be small on this screen, but found that the null, for their data, was 10.76 times more likely than the alternative. They found evidence in favor of the null. Second study. This is about shoot-'em-ups. For those of you who are unfamiliar with this, shoot-'em-ups are a kind of video game in which you have a first-person perspective, look at the world and shoot a bunch of aliens or otherwise like ill-tempered creatures that are after you. And the idea here is that for a group of non-video gamers that are trained on these kinds of shoot-'em-ups will lead to faster cognitive processing. I need to be very explicit here. The claim is not that the existing group of video gamers process information faster than the existing group of non-gamers. No. Explicit practice, the manipulation of practicing these video games, would lead to beneficial cognitive processing. Also, this effect is meant to hold up over different kinds of video games, like SimCity, in which you do more cognitively oriented things. And then finally, the claim is about cognitive processing and not just faster motoric processes. In a study by myself and collaborators, we have replicated this study, and by analyzing our results, we found that, in fact, the null is 23.5 times more likely. Again, a conclusion you cannot reach by traditional null hypothesis significance testing. Finally, the last one I would like to bring up is the claim of creativity. The claim here is that if you are in a frame of mind in which you process information in a global manner, this will lead you to subsequently be more creative than if you process information in a local manner. The operationalization chosen by the original researchers is such: you look at a display of letters, and if your task is to assess the global gestalt, if you will, in this case, it's a big H comprised of smaller L's. If you are supposed to identify the big letter here, then you will subsequently categorize a penguin as more typical of a bird than if you are supposed to categorize the local, the small letters, the L's. Again, a replication study was conducted, and it was found that the null was 10.35 times more likely. I'm not trying to argue a case here for any of these specific research paradigms, even though I have a personal opinion about them, but I'm arguing a case for the method. I'm arguing that if you want to do these kinds of studies, it is crucial that you don't measure with one evidence criterion, because it rigs the field. It's very important that you can find evidence both in favor of your null and in favor of your alternative. Now, I believe I have about 0 time left, so I'm going to leave it at this. Thank you very much for your attention.